Earlier, we showed you some three-point shots. Professional basketball players such as Stephen Curry, Kyrie Irving, James Harden, and LeBron James can make a three-point shot look easy. Why? Because they know how to shoot a three-pointer and they are shooting basketball for the rest of their lives. But today, we're going to talk about how normal people can shoot three-point shots using physics.
First of all, a three-point shot is made when a ball from beyond the three-point line enters the basket. It doesn't matter how the ball is thrown. The three-point line's distance from the hoop is varying among different leagues. In this video, we are going to consider the International Basketball Association or FIBA's three-point line standard, which is 6.75 meters away from the basket. But considering that you must shoot beyond that line, we will be using 6.8 meters as your distance from that hoop or basket. The hoop is approximately 3.05 meters above the ground.
Also, in this case, we're going to talk about the basketball as a projectile. For that reason, ball spin and air resistance is negligible.
Shooting a basketball to the hoop will require you to exert force to the ball at a certain angle, and that will give it its required initial velocity at a certain angle to go through the hoop. Different people have different muscle strength, so some people will not be able to apply enough force to the ball for it to have high initial velocity.
Shooting a ball at a certain angle will require a specific initial velocity to pass through the center of the hoop. Let's say you're going to shoot the ball at angle A. The ball needs to have an initial velocity of V.
We need to find the optimal angle for you to shoot the ball, since players with different heights have different optimal angles, where they can have the best chance of making the three-point shot a success. You can find the optimal arc using this equation.
You're taking me higher and higher when we love.
We will use the height of the hoop, which is 3.05 meters, as our h, and height of the ball before the release, which is approximately 1.80 meters, as our h. Subtracting the h from h, we can compute for the h, which is 1.25 meters. We will also use the horizontal distance of the ball before the release to the ring, which is 6.80 meters, as our x. Substituting that to our equation, we will be having get a 50-degree optimal angle. Now we need to find the initial velocity of the ball that will be launched in a 50-degree angle. We will be using the second equation of kinematics, which is then, using the horizontal distances first, we will substitute it to our equation. Since there is no acceleration involved in horizontal distances, we will cancel the 1/2 at squared. Also, since the initial position is 0, we will also cancel it, leaving us x equals velocity times time. Solving for t will give us t is equals to x over velocity. Also, since it is only for horizontal distances, velocity along x will be velocity cosine 50, since 50-degree angle is our launch angle. So, the final first equation is t is equals to x over v cosine 50, where x is 6.8. We will then use the vertical distances and vertical factors into our second equation. So, the equation y is equals to y 0 velocity sine 50 times t plus 1/2 gt squared will become 3.05 is equals to 1.85 plus v sine 50 times negative 9.8 times t. We will then input our first equation into the equation, getting 3.05 is equals to 1.85 plus v sine 50 times x over v cosine 50 plus 1/2 times negative 9.8 times x over v cosine 50. After that, we just need to simplify this equation and solve for v velocity. 3.05 is equals to 1.85 plus v sine 50 times 6.8 over v cos 50 plus 1/2 times negative 9.8 times 5. Since v sine 50 and v cosine 50 could be written as tan 50, we will be having 3.05 is equals to 1.85 plus tangent 50 times 6.8 plus 1 half times negative 9.8 times 6.8 over v cosine 50 squared. And it will give us negative 4.9 times 6.8 over cosine 50 squared all over negative 6.90, which would give us the velocity of 8.91 meter per
and
second.
higher when we love.
So, in conclusion, you have now learned that the perfect or optimal shooting degree angle is 50 degrees for shooting a perfect 3-point shot. Again, shooting at a 50 degree angle would give you the best chance of shooting a perfect 3-point shot. But it will not always be that case. You must practice it with consistency in order to ensure that your 50 degree angle shot would result to a perfect 3-point shot.